Good morning, everyone. Thank you for hosting me in your beautiful country and city. My name is Eran, and I'm leading the functional testing solution in Microfocus. And in today's session, we're going to talk about test automation and beyond using artificial intelligence. So let's get started with first understand what is happening and what is the state in the market in AI and what the business priorities are. So 83% of businesses sees AI as a strategic priority for them. This is a huge number. 40% of digital transformation initiatives, and I'm pretty much sure you heard about the DevOps, the Agile, and all of this digital transformation hype, are going to use AI in order to implement it. And more than that, 31% of IT professionals are looking nowadays how they are going to invest in AI in the next 12 months. But those are more of futuristic stuff. Those are like predictions. Let's see what is happening nowadays in the AI market. 23% of the businesses have already incorporated AI into their processes, services, and products. More than 60% of businesses says that the pressure to reduce cost will require them to use AI. They definitely see it as a significant option in order to reduce cost. And more than 50% of executives says that AI solutions and implementations has already showed productivity and increase in efficiency. But up until now, I use the term AI as a buzzword. And in this session today, it's important for me to convey to you the message of what is AI and how that can be applied in our space, in the testing space. So let's talk a few minutes about AI. What is AI? AI is a broad category of software, include machine learning. The software is trained to do a simple task. A simple task can be categorized as something that a human being can do in less than a second in order to solve a simple problem. The most of the AI engines, usually it's pattern matching. And we are going to show you some interactive stuff around what pattern matching is. The base AI engines consist of inputs, comparing to outputs, and comparing to expected results. And eventually, these applications that use the output of the AI trained process will apply it to solve specific problems, such as MRI scans in the healthcare, such as recognizing a stop sign in the automotive space, in the autonomous driving, or even to compose conversation with their stylists. But let's take AI into our space, into the test automation space. And I'm pretty much sure that each and every one of you can find yourself in one of those three cubes that we have here. We have the shift left, the shift right, we have the dev testers, we have the automation engineers, and we have the business users. Each and every one of those users, which I guess pretty much cover the guys that sits in this room, face challenges in today's reality. And today's reality is that we have the fast-paced releases. The fast-paced releases, it's because of this is a business need. We need to release faster. It's not the times anymore to release a 6 months releases, 12 months releases, 18 months releases. It's more of quarterly releases, monthly releases, and even bi-weekly releases. Those releases eventually carry frequent app changes that leads to two main disruptions that you guys face on a daily basis. The first, automation coverage. Due to those fast-paced releases and frequent app changes, we cannot exceed a significant number of automation coverage. Usually it will be around 30%. And the immediate thing that will happen right after is high maintenance cost. The high maintenance costs, the numbers that we see in the market, it's roughly between 30 to 50% of maintenance time invested in the assets that you have already managed to create. What we looked at in Microfocus in the last 12 to 18 months, this is what we are getting from our customers, and this is something we would like to address. What are the things that we can do within the product, regardless if this is AI, if it's not AI, we do have many features that will help you to break the ceiling glass of automation coverage, while at the same time, reduce dramatically the maintenance. Let's take an example of today's reality. E-commerce application Think about Amazon, think about eBay, think about any e-commerce application that you would like to think about, and we want to have a simple business process of buying an item. We need to log in, we need to find the item, we need to choose it, we need to process the payment process, the shipment, and that's it, we can buy. But what it means that we don't need to test it only on iOS, because we need also the Android, and we need also the mobile web. This one creates a challenge, because we need not one single script, 3 different scripts for the mobile. One for Android, one for iOS, and one for mobile web. That is a challenge. This is something that will carry time to market. And think about application change, maintenance. We don't need to maintain once, we need to maintain 3 different scripts. Now this is relatively a simple example. Think about your complex business processes. You face this reality on a daily basis in your organization. And this is what we see from our customers, and this is what we would like to address. Now, let's take a look at UFT. Okay, can you play the video, please? Video is not playing. So this is UFT, and this is a script that will cover the Android. And we will go and log into the system. Simple and easy task to perform. We did a script, we did it for iOS, we did it for Android, we did it for mobile web, and everything is just great. But now we are going to introduce a change. The change will be a simple one in order to convey the message. We flip the order of the menu and the cart, as you can see here, and we also change the way we identify the object, the underlying object properties. And I guess you can imagine to yourself what will happen. And for that, let's use the next video. Can you play it, please? Okay, it's playing. So you can see here that, unfortunately, with all the great stuff that we have within the unified functional testing, this simple change of changing the way we're interacting with objects will cause to the script to break the automated test, because we cannot identify this object anymore as we used to identify it. And we as a QA teams cannot control the development teams to keep up on the objects that we are relying on. So, what is happening? We are counting on the object identification. The once it's being changed, test is broken. What if there was a way to equip unified functional testing with eyes like a human being will see it? Because if I'll give you a mobile phone, and I'll ask you to perform the same scenario on an Android, on an iOS, on a mobile web, if the menu and the cart will be in the flipped order, that won't break you from executing the test. And this was the thinking process. If we can equip UFT with eyes, a human being eyes, that will help us to identify the objects in a different way that we did it in the last 20 years. Now, in order to do so, we started to research some of the AI areas that exist out there, and we decided to focus on those 3 key elements. The perception with the computer vision techniques to identify the objects, and deep learning in order to understand how to interact with the object and what exactly we see on the screen in order to be able to manipulate it. In order to do the deep learning, actually today there are 3 main techniques: the supervised learning, the unsupervised learning, and the reinforcement learning. Usually in computer vision we will go with the supervised learning, and I'll show you an example in the next few minutes. Now, in order to convey the message about computer vision, deep learning, we will do some interactive session now. Now I need a volunteer, please, that will help me to understand what we see here on the screen. Believe me, it is related to the test automation eventually. So can I find one volunteer, please? Someone, or I'll pick someone by myself. You. What do you see here on the screen? Yes, what do you see here? 3 dogs. Okay, thank you. Almost. Because what you see here, it's a dog, and a cool dog. The next question for you, yes. So what do you see here now? Cat and a cool cat, which is a great answer. Perfect. But Did you ever imagine to yourself how this magic happened right now? This is a simple task that we are doing thousands of times a day, using the eyes, using the ears, using the smelling, using the touch. This is being done by seeing a picture, being able to classify it, identify it, and giving it the right name. As simple as that. This is being done by us, equipped with our brain and neural networks, that this is their main day job. And a neural network that will identify a cat and a dog, this is something that we all have. But something even more amazing happened. I showed you a picture of an animal with the sunglasses, and I told you that this is a cool animal. The second time I showed you an animal with the sunglasses, you immediately categorize it as a cool animal. So your brain were capable of seeing something, learn in a supervised learning. I was the supervisor, and I told you that when you see an animal with the sunglasses, from now on, this is a cool animal. Okay? And let me try one more thing. Can you stand up, please? What do you see here? A cool man, right? It's easy as that. But if I'll show this baby that born just yesterday, that's a cat and a dog, he will not be able to distinguish between a cat and a dog. Something is happening, and when this baby gets to 1 year old, he usually can say, maybe not a cat and a dog, a how and meow, but something happened to this baby. Someone was responsible to develop his neural network to identify a cat and a dog. And those were the supervisors, teach by example, mom and dad. This is a cat, this is a cat, this is a dog, this is a dog. And the baby started to develop his neural networks, and the way he did it with the supervised learning and understand what the features that categorized a dog and a cat. Features can be legs, can be the height, can be the ear, can be the nose, can be the eyes. And those are the features that helps to the baby to identify a cat or a dog. Now let's move on to the next example. What do you see here? Maybe you. It's a simple thing. What do you see here? Login page. I see something different. I see a picture with 2 text inputs and 1 button. There is some text around those input fields, and the button is in a different color. And in the button, we have the name login, sign in, submit, whatever. My brain capable of seeing a collection of images and categorize it as something. So if we are capable of doing it so easily in less than a second, why computers won't be able to do the same? But it's all started in the early 50s, right? It started with the artificial intelligence in the early 50s. Early 80s, we saw the machine learning, and back then the IBM Watson that managed to develop the machine that won the worldwide champion, Mr. Kasparov. But something happened in 2010, which is the deep learning that created the AI boom. But something even more impressive happened in order to allow the deep learning. And what we saw is the big data and the ability to process thousands and millions of records in a matter of seconds. The computing power to do the image processing was something affordable. And today, with the machines, we are capable of identifying 25,000 images in less than a second and classify those. And in addition, we also saw the evolvement of the various deep neural networks. Deep neural networks, it means that we have several layers, the input and output and hidden layers, and we have thousands of neurons inside that take the decision of what they see exactly on the screen. Because at the end of the day, we are human beings, we have eyes, computers have 0 and 1s, and we need to find a way to teach the machine, to learn the machine how to identify and how to see things with 0 and 1s. Once we have that, we also started to see the companies and the enterprises adopting the techniques on top of the program. In that case, for example, in the automotive space for autonomous driving. Let's see some example about industries that adopt the AI and deep learning. So we have the internet services with image and video classification. We have the medicine with cancer cell detection and drug discovery. We have the media and entertainment with video captioning, content-based search, and real-time transition. For those of you still using Facebook, I guess that you saw the Facebook challenge a few months ago, put your picture from 2009 and 2019. That was a brilliant move of Facebook to get faces and use it to train their own artificial intelligence engines to identify faces. And we have the security and defense for surveillance and others. And last but not least, the automotive and the autonomous machines. Now, what we also start to see, for example, we have the AI VA. AI VA, it's an artificial intelligence soundtrack maker. And this is the official company that NVIDIA used in their conference to create the soundtrack. So if you want to create a new sound of yours, a new song of yours, you just put the lyrics. You said if you wanted to have it as a happy song, as a fast song, slow song, sad song, and the song will be created for you without any composers behind. And this is being done by training AI system with tons of samples from various music artists. Now, having those all in the street, understanding that we can identify images, we can train those machines in order to be able to see as a human being, we have developed our own AI engine that is based on computer vision and deep learning, that's capable of identifying objects in a totally different way than it was up until today. And trust me, this is a change in paradigm. So no need anymore to go to the underlying properties and object to identify them. Think about the fact that now UFT, and later on also the rest of the solution, is equipped with eyes. And I'm going to show you a short video of how it looks. So you can see here, UFT with the new SDK, AI Util. This one will be used to process the same business process I was talking about. And guess what? You need only one script for mobile, Android, mobile iOS, and mobile web. You have a much more flexible way to interact with the objects. And you can see here that we don't have object repository anymore. So if you will go to the object repository in UFT, you will find there nothing because we don't need the objects, because we have the eyes of UFT that will help us to do this task. So this is one thing. And actually, if you remember, we said that we have the dev testers, we have the automation engineers, and we have the business users. This will be perfect fit for the COEs and to the dev testers that works with UFT, knows to do the basic scripting and so on and so forth. For the LeanFT, if they want to work in their IDE. But what we also realized is because of the fast-paced releases and the need of having a much more fast and speed to allow also to manual engineers, we have added into our solutions one more area from the AI space, which is the NLP, in order to help you with this design. And for that, I'll show you one more example. If I'll ask you now, can you please search a dog in Google? Think about it for a second. Usually what you're going to do, you're going to open either your mobile or the desktop. You're going to navigate to the browser. You're going to go to google.com and search the name dog. Click on the search button and analyze the results. Those are usually the 5, 6 different steps. But I only ask you, can you please search a dog in Google in a very natural language way? So what we have added, we understood that we want to equip our tools with this exact approach. So instead of you creating 5, 7, 8 different steps in order to do this simple task, you will be able to write in a new syntax, natural language way, what exactly you want to do. So for example, I'll show you a demo now, and you will be able to see that with a simple syntax that each and every one of your manual engineers can understand, they can create the assets, equipped with AI engines and the computer vision, then this is a different ball game than we had up until today. So let's see this demo in a second. What you see here on the left side, you can see the new syntax, and if you read it, you will understand that this is a very basic one. We are choosing all the 3 platforms at the same time with Android, iOS, and mobile web. You can see on the right side, I like to call it the UFT eyes, so you can see what UFT sees. You can see the rectangle along the objects, and please pay attention to step number 6. Search for 70T. It's the same like you're going to search a dog in Google. It's a one single, simple syntax just to guide UFT. Dude, please look for the search button, insert the 70T in the text input, click on the search button in a single line of code. And it's not a code, it's more of a natural language way. So what you can see here is this exact way of running against the 3 environments. I'll skip in order to summarize what we started with. So those are the challenges: fast-paced releases, low automation coverage, and high maintenance cost. Using what I just showed you, we are going to increase the reliability and the resiliency of the assets. Automation can actually be much higher and break the ceiling glass than we have up until today because of the resiliency and because we can allow other users to join to the automation party. And maintenance will be reduced dramatically because we have much more resilient assets, as well as we don't need few scripts to do the same simple task. Last but not least, remember the example. This is the reality that we have today. And the reality of tomorrow, it's AI testing tool equipped with out-of-the-box reliable language using NLP services. Create once and let automation run it for you. And reduced maintenance as a result of these resilient assets. Now, this is not a science fiction. You can come to our Microfocus booth right after this session and see this in action. It is already available as early access, and you can try it on your mobile applications within your organizations. Thank you. Questions?
Okay. We have two questions about the maturity of this solution and the plan, obviously, for delivery.
That is a great question. So the maturity, so we have worked on what you just saw for the last 12 months, evolving our own AI engine. Now I can tell you the AI engine won't be perfect at day one. But the good thing with Microfocus is that when you are doing the work with UFT, if object won't be identified because the AI won't work, you can still work with the traditional way of UFT, of identifying this object. You will have a way to communicate with Microfocus in automate ways, say this object is not identified in my engine, please improve your AI engine, and you will get an improved engine. By the way, the engine won't be custom per customer because this AI engine will know all the enterprises software worldwide, and think about it, it's going to be the Superman tester.
And another question is regarding the supervisor of AI. What is? There is another intelligence to control this intelligence, so
yes.
Is more
so the the supervised learning, it's mainly taking test data, okay, taking images of snapshots of objects, starting with a pre-trained network, train the neural network with something that exists out there in the market, which we believe this is the way to go, and put on top of that the test data that we already have and got from our customers and partners. This is the baseline that we are going to start with, and this is going to improve as we move forward. But think about it just for a second. We have thousands of customers worldwide. We have hundreds of users, millions of tests running on a daily basis, which means that we are positioned best in order to get the data that is currently not being identified and make sure that the AI engine will work tomorrow in a much better way than it is today.
Grazie, thank you.
Thank you. Thank you, guys.